This video is all about differentiating the hyperbolic functions. When you differentiate sinh, you get cosh. When you differentiate cosh, you get sinh. And when you differentiate tan, you get sech squared. You should note these are similar results to the trigonometric functions. We know that when you differentiate sine, you get cos. We know that when you differentiate cos, you get minus sine. And when you differentiate tan, you get sec squared. So notice that these results are very similar. The only difference is that we actually have a cos differentiates to positive sinh, not negative. So I'm going to show you why that's the case and show you how you can prove these other results as well. And we can do that from the from the exponential definition of these. So I'll show you how we can do it for cosh, and then you can do it yourselves for sinh and tan. So we know that cosh is the same thing as e to the power x plus e to the power minus x all over 2. So differentiating this, so first of all differentiating the exponential e to the power x, I would get e to the power x. Then differentiating the e to the power minus x, well, the e to the power minus x differentiates the e to the power minus x times minus 1 because of the minus there. So minus e to the minus x. All of that is over 2. And we can see that this is the same thing as positive sinh. Remember, sinh is defined as being e to the power x minus e to the power minus x all over 2. Excuse me. So there we go. I have proved that differentiating cosh, you will get sinh. So let's do some more examples with some slightly hard functions. So here I want to differentiate cosh 3x. Well, I know that cosh differentiates to be sinh. So I would get sinh 3x. But by the chain rule, I'm going to have to multiply by 3 because that's the derivative of the inside. So cosh 3x would differentiate to be 3 sinh 3x. We're now going to differentiate x squared cosh 4x. So we're going to have to use the product rule here because we've got the product of x squared times cosh 4x. So using the product rule, I'm first going to differentiate the x squared to get 2x, and then multiply that by the cosh 4x. I'm now going to differentiate the cosh 4x and multiply it by the x squared. So I'll get x squared multiplied. So cosh differentiates to be sinh, so I'll get sinh 4x. But by the chain rule, I'm going to have to multiply this by 4 because that's the derivative of the inside function. So timesing this by 4, I'll get 4x squared sinh 4x. So that's it. That's x squared cosh 4x differentiated. You can also differentiate the inverse hyperbolic functions. So r sinh differentiates to be 1 over x squared plus 1 over the square root of x squared plus 1. R cosh differentiates to be 1 over the square root of x squared minus 1, and r tan differentiates to be 1 over 1 minus x squared. I'll show you how we can do these. We can follow a similar process to how we differentiated inverse trigonometric functions. So I'm going to show you that differentiating r sinh gives the 1 over the square root of 1 plus x squared. So if I let y equal r sinh x, I'm then going to take sinh of both sides. So sinh y equals x. I'm now going to differentiate both sides with respect to y. So sinh is going to differentiate to be cosh, and then I will differentiate x with respect to y. Now, I want to obviously get dy by dx, not dx by dy, so I'm going to take the reciprocal. And obviously I want to have this in terms of x, not in terms of y. So I need to replace that cosh y with a function of x. Now, remember that cosh squared, that should be cosh squared x minus sinh squared x is 1. So I can use that identity to help me. I can say that cosh squared, it will be y in this case, is going to be equal to 1 plus sinh squared y. So cosh y would be equal to the square root of 1 plus sinh squared y. And obviously I know that sinh y is x. So sinh squared y will be x squared. So therefore I can replace that cosh with the square root of 1 plus x squared, and that's the result that we wanted to prove. So similar technique to how we differentiated the inverse trigonometric functions. The only difference is it's hyperbolic instead. Okay, a couple more examples using that now. So I want to differentiate y equals x times r cosh x. So I've got the product of two functions here. I've got the product of x and r cosh x. So I'm going to use the product rule. So let's differentiate the x first, and we'll get 1 times r cosh. Now we will have x times the derivative of r cosh. The derivative of r cosh, and you can just state this from the formula booklet unless it asks you to prove it, is 1 over the square root of x squared minus 1. So just simplifying that then, we'll get r cosh x plus x over the square root of x squared minus 1. And last example for this video. So we want to, given that y is arc cosh x all squared, we need to prove this result. The x squared minus 1 times the dy by dx all squared is equal to 4y. So clearly I can see I need to differentiate here. So that's going to be my first job. I'm going to differentiate this function. And I'm going to do so with the chain rule. So dy by dx. So first of all, let's differentiate the outside function. Let's differentiate that 2, or rather that squared. So that means I'm going to multiply by 2. I'll get 2 r cosh x. The new power now will be 1, because obviously the 2 take away the 1. But by the chain rule, I need to multiply this by the derivative of that inside function, by the derivative of r cosh, which we know is going to be 1 over x squared, the square root of x squared minus 1. Okay, so that's me differentiating this using the chain rule. I now need to make it look like this. So first thing I'm going to do is I'm going to multiply to get rid of this awkward fraction down there. So I'm going to times both sides by the square root of x squared minus 1. I'm then going to square both sides to get rid of this square root. So if I square the left-hand side, the square root of x squared minus 1 will just become x squared minus 1. The square of dy by dx will become dy by dx all squared. The right-hand side, squaring 2r cosh x will give me 4 lots of r cosh x all squared. And now let's just remember that r cosh x all squared was just equal to y. So I can replace all of that with y. And that gets the result that we needed. So, nothing brand new in this video. The only thing really is these results, using them with the chain rule, the product rule, quotient rule as well, and also using these results. You can state them, they are given to you in the formula booklet, but you do need to be able to prove them as well.